Okay, so what's the point of statistics, right? What is the whole point? So I'm going to tell you a story today. I'm actually going to tell you the story about 10 different times. This story is so unbelievably important, and it's the foundation for everything we're going to do. So we really need to understand this story. Basically, we're going to want to answer a question about a big group of people, like everybody who lives in the United States, okay, which is a huge amount of people, right? Or everybody who lives in the world, or maybe let's make it a little smaller, like everybody who lives in California. That's still like, 20, 30 million kind of thing. So we have a question, but the question is about a big group, okay? And to answer the question, we would have to collect data. Like, okay, like let me make up a question. Like, I want to know what's the percentage of people in California that are married. Let's say I want to know that answer. What percentage of people in California that are married? So how would you figure that out? The question is about everybody. The question is phrased and it's about everybody in California. How would I figure out the percentage of everybody in California that's married? The answer is you'd have to talk to everybody in California. And you'd have to ask them, are you married? And they would say yes or no, kind of thing. And you'd have to talk to like 30-ish million people. Okay, so that's insane. That's way too many people to talk to. But that's the question. Sorry, the question is about all people in California. So every stats question is about a big group of people. It's not always people, but okay, most of the time it's people. But in order to answer the question, you'd have to collect an insanely huge amount of data that you don't want to collect. There's just too much data. Like, I don't want to talk to 30 million people. That would take forever. Or if I hire people to do it for me, it costs me a lot of money or something like that. So what do? That's where stats comes in. Stats is going to say, okay, I'm going to still answer the question, but I'm not going to collect data from everybody in California. I'm going to collect data from just some people in California. Like, for example, maybe I go somewhere and the first 100 people I see, I ask them, are you married? Okay. I don't ask all 30 million people if they're married. I just ask the 100 people, are they married? And just from the answers I got from the 100 people, I'm going to answer the question that I was asked about this entire big group of people. So let me say it again. The question is about a big group of people, but we're going to only, and we're going to answer the question about the big group of people. But the way we're going to do it is we're going to only talk to a small part of the group. We're not going to talk to the whole group. We're not going to collect data from the whole group. Okay, so big group of people, okay, that the question's about, but we're only going to talk to this portion, okay? We're going to get the data from them, and we're going to answer the question about them. Now, at this point, you might be like, how the heck is that possible? And if that's what you're thinking, then you're understanding what I'm saying. It seems weird. How can I answer a question that's about 30 million people by only talking to 100 people? How is that possible? And the answer is, it is possible with stats. It's just a long story. It's, 13, 14 chapter story. Okay, is what I have to give you to be able to do that. So that's what stats is. Stats is a bridge from this small group where we have the data to the big group that the question is about. Okay, I'm going to say that a whole bunch more times. So here we go. The goal of statistics is to answer a question about a big group. So the question is phrased about a big group, but we're going to collect data from only a small part of the group. Again, if I want to know the answer to a question about a big group, I'm supposed to collect data from the entire big group, but we're not going to do that. This is too much trouble. We're going to collect data from a small part of the group, and from that, we're going to answer the question. So let's read this again. We want to answer a question about a big group by collecting data and analyzing data from a small part of the group. I just want you to understand what I'm saying, okay? How we're going to do that is a whole, it's actually, I said 13, 14 chapters. It'll take us to chapter 9 till we can do this, okay? So it's going to be a few chapters to understand how to do it. I just want you to understand what I'm saying. It should sound weird to you. We have a question about a big group that we're trying to answer. The only way that it makes sense to answer the question is to collect data from the entire big group, but we're not going to collect the data from the entire big group. We're going to collect data from just a small part of the group. We're going to talk to just a few people and answer a question about a much bigger group of people. Okay, now I'm going to give you a different, I'm going to say the same thing in a slightly different way here. So here's a different kind of example, but same idea. A bag contains many numbers in it. So we have a huge bag with a bunch of numbers in it. I'm imagining, you know, there's a bunch of racket balls in this bag, and each ball has a number written on it. Okay, so there's a huge amount of numbers in the bag. Okay, so millions or billions of numbers in this bag. You put your hand inside the bag and you're going to draw 4 numbers out. So there's the hand. We're going to draw 4 numbers out. And the numbers we draw out are 5, 5, 17, and -2. Here they are. Okay. But now take a look at the question. Here it comes. Question is, what is the average of all the numbers in the bag? If you are paying close attention to this problem and you're saying, I don't know the answer, that's impossible, then you're getting it. Okay. I'm asking for the average of all of them. I don't know them all. How can I figure out the average? Well, we will be able to figure it out after chapter 9. Okay. But for right now, what's the average of all the numbers in the bag? We don't know the answer. I only have 4 numbers drawn out of the bag. I can find the average of those 4, but that's not what they said. They said find the average of all the numbers in the bag, all of them, not just the 4 numbers that we drew out. Okay. So let's take a look at this problem and see if you can identify the groups. There's a big group and there's a small group. What's the big group? Can anyone tell me what the big group is?
The big bag of numbers?
Yes, this is the big group. This is the group the question is about. Okay? Can someone tell me the small group?
The small group is the 4 that you pulled out of the bag.
It's the 4 numbers that we drew out of the bag. This is the small group. That's right. Is the question about the big group or the small group?
Big group.
The question is about, here's the question. It's about the big group. What is the average of all the numbers in the bag? Okay, the question is always about the big group. But do we have data for the entire big group? Do we know all the numbers in the bag? No. We know the numbers in the small group. So we have data in the small group, but we want to answer a question about the big group. Now in this problem, I could find the average of these 4 numbers. The way you find the average is you add them and you divide by how many you have. So if you did, 5 plus 5 plus 17 plus -2, that's 25. And then you divide by 4. 25 divided by 4 is 6.25. 6.25 is the average of these numbers. Do I want to know the average of the numbers in the small group? Yes or no?
No.
No. I want to know the average of the numbers in the big group. Tell me, what is the average of all the numbers in the big group? Someone tell me. So it was a trick question. Let me ask the question again. What's the average of all the numbers in the big group?
We don't know.
We don't know. It's the right answer. Yes, we don't know.
We don't know.
We don't know it. What's the average of all the numbers in the small group?
6.25.
6.25.
6.25. So I know that average. Is that the average I want to know?
No.
No, I want to know the average of all the numbers in the big group, and that's the question. That's how it works. Now, all we can do for now is make a guess. So if I asked you what's the average of all the numbers in the big group, you would say, I don't know. Okay. But if I said make a guess, then you would guess 6.25. Now that's a very bad guess, but that's the only number you have to go on because this is the data you have. Okay. So what's the average of all the numbers in the big group? Don't know. What's your best guess for the average of all the numbers in the big group? For right now, what is it?
6.25.
6.25. Is it right?
No.
Probably
Maybe.
not. I guess we could have got lucky and it'd be right, but probably not. Okay, so that's the story. I'm going to tell you the story again. I'm going to keep telling you the same story that I'm telling you. Okay, let's do a different example, but same story. Okay. You want to know the average age of all Rio Hondo students. Since you don't have time to talk to all 20,000 Rio Hondo students, you decide to ask the first 10 people you see at Rio Cafe at noon for their ages. The ages you obtained were 17, 18, 18, and so we obtained these ages, and the average is 22.6. What is the average age of all Rio Hondo students? Okay, I want to pick this problem apart. Someone tell me the big group.
Students at Rio Hondo.
Yeah.
1,000.
Okay. So the big group is all Rio Hondo students. The question is about all Rio Hondo students. We want to know the average age of all Rio Hondo students. Some people said 20,000. Let's talk about communicating a little bit here. These groups are usually groups of people. So if you're going to write 20,000, it's not clear enough. If you put the number 20,000 in your answer, it's fine, but don't write just 20,000. If you write the 20,000 Rio Hondo students or something like that, all 20,000 Rio Hondo students, it's fine. If you just said all Rio Hondo students without the 20,000, that's fine. I'm not asking you to count how many are in the group. I'm asking you to describe that group of people in words, kind of thing. Okay, so the big group of people is all Rio Hondo students, or all 20,000 Rio Hondo students. That's fine too. That's the group, the big group that the question is about. Okay, who can tell me what the small group is?
The first 10
10
people.
The 10 people, yeah, the 10 people that we talked to, right? The 10 people that whose age we asked. Okay, cool, that's the small group. So the first 10 people you see at Rio Cafe, that's the small group. Okay, let me put big group here, small group here. Do I have the data for the big group?
No.
No.
It's like I'm asking, did I get the ages of everybody in the big group? No. Did I get the data for the people in the small group?
Yes.
Yeah, that's always how it's going to work. So here's the data for the people in the small group. And the average of those 10 numbers is 22.6. If you add all 10 and divide by 10, hopefully I did it right, you get 22.6. But again, the question is, what's the average age of all Rio Hondo students? All right, tell me the answer. What's the average age of all Rio Hondo students?
Don't know.
We don't know. What's your best guess?
22.
22.6.
22.6. Is it a good guess or a bad guess?
Bad.
It's probably a bad guess. Right. Okay. So again, I just want you to identify there's the big group and the small group. The questions about the big group, we collect data from the small group. And we can use our small group answer to guess the big group answer. And that's as far as we can go with the story until we get to chapter 9. All right. The next slide I go to is still related to this exact problem. So don't forget this problem. Okay. But now what I want to do is go one step further and I want to visualize what's going on. So remember, every stats problem is about a big group. I want you to visualize the big group as a big bag with people in it. That's what that is, big bag of people. In the question we just did, this big group of people, describe it in words for me.
All Rio Hondo students.
Yeah, okay, all Rio Hondo students, right. Now at this point, I do want to mention to you that whenever you're describing the big group, this word is super important. The word all is unbelievably important as far as being clear about things. If you don't write this and you just write Rio Hondo students, you might be thinking the right thing, but the big group and the small group are both Rio Hondo students, okay? So which Rio Hondo students are the big group? All of them. So that word all is super important. Please don't forget to put it. I often take off points when people forget to put it. Okay, so all Rio Hondo students, that's the big group of people in the last problem. Do we collect data from this big group of people?
No.
No. But if you imagined you did, I know we don't, but if you imagined you did, I want you to visualize that as a big bag of numbers. I want you to think that each of these numbers is the answer when you ask the question from this person. What question are we going to ask? We're going to ask, how old are you, right? When we ask this person how old they are, their age is here. When we ask this person how old they are, their age is over here. When we ask this person how old they are, their age is here. And each one of these people, if we asked each one what their age is, we get this big bag with numbers in it, okay? Now this big bag of numbers, if I said describe it in words, who can describe this bag of numbers in words? It's a little tough.
The age of all Rio Hondo students?
Yeah, it's the ages of all Rio Hondo students. You would want, don't write the age of all Rio Hondo students. That actually doesn't make too much sense. But if you say the ages, it's like, it's a bunch of ages, okay? It's the ages of these guys, okay? So this is the big group, the group the question's about. We don't collect data from them, but if we did, you'd visualize it as a big bag of numbers. It'd be the ages of these people. Okay, now, again, we don't have this data, but if we did have the data, then we could calculate the average of all these numbers, but we can't, we don't have the data. But if we had the data, we calculate the average of all these numbers. And that's what we want to know. We want to know the average age of all Rio Hondo students, which is the average of all these numbers, but it's an unknown number because we don't have the data. Okay, so there's really three pieces involving the big group, and there's going to be another three pieces involving the small group. There's the big group of people the question's about. If you ask everybody in that group the question and get all the answers, that's this big bag of numbers over here. but we don't collect that data, okay? But if you have, it's an imaginary bag of data, okay? We don't collect it. But if we did have this data, you could calculate the average of those things. Okay, this is a big group of people. This is a big group of numbers. And this is one number. It's the number that we're looking for. But we don't know it because we don't have this data. We don't have this data because we didn't talk to all these people. So this is an imaginary bag of data, and this is a number we're dying to know, but we don't know because we don't have the data for it. Okay, then there's also a small group, right? So in the example we just did, so first of all, a small group of people, I want you to visualize that as a small bag of people. Now I know if you count in there, you're going to see that there's 6 people, but there isn't 6 people. How many people are in this small group?
10.
There's 10. Describe it in words for me. So describe this group of people in words.
First 10 Rio Hondo students.
The first 10 Rio Hondo students that we talked to at Rio Cafe, something like that. Yeah, the people we talked to, right? What did I write over here? The 10 Rio Hondo students polled at Rio Cafe at noon. I know you only see 6, but don't count them, right? Like over here, if you count, there's like 20, but there's 20,000, right? So don't count them. Do we collect data from this group?
Yes.
Yes.
Yes. And I want you to visualize that as a small bag of numbers. Again, it looks like 6 numbers. It's really 10 numbers. Who can describe this data in words for me?
Ages of 10 Rio Hondo students.
Yeah. The ages of these people, right? The ages of the people we polled. Let's see what I wrote over here. Ages of the 10 Rio Hondo students who were polled at Rio Cafe at noon. All I really did was I wrote ages of, and then I copied this down. Okay? Ages of, and then I copied this down. Ages of them. Ages of them. Okay? Cool. Now, we do have this data. So I could find the average age of this. I want to know the average of these numbers, but I don't know those numbers. But I can find the average of these numbers on the bottom because we did collect the data. Here's the data, and the average is 22.6. Okay, so again, as far as the big group goes, big group of people, big group of data, but it's imaginary data, we don't collect it. But if we had that data, we can figure out this one number. And ultimately, this is my goal. What is this number? That's what the stats question is asking. What is this number? Okay. But again, what do? You talk to a small part of the group, a small group of people. You do collect data from them, and you calculate the number you want, but not from the big group, from the small group, and you get 22.6. That's one single number there. Now answer this question. What is the average age of all Rio Hondo students?
We don't know.
We don't know. We don't know exactly. Okay. What's the average age of the 10 students we talked to?
2.6.
22.6.
22.6. What is your best guess for the average age of all Rio Hondo students?
22.6.
Yeah, this number is your guess for this number, but it's just a guess and it's probably wrong. Okay, so this is what I want you to visualize. Every stats problem really has these 6 components. Big group of people, small group of people, big group of data that we don't have, small group of data that we do have, a number we're dying to find, another number that's going to be our guess for this number, and that's really all we have so far. All right, any questions on that?
Yeah, I have one.
Go ahead.
So when you're describing, like, for example, the 10 Rio Hondo students polled at Rio Cafe at noon, do we have to write polled at Rio Hondo Cafe at noon? Or can we just say the 10 Rio Hondo students? Like, because it doesn't matter, like, what 10, your number's still going to be the same at the end.
Here's what matters.
I'm just wondering.
Yeah. Here's what matters. What matters is you be clear. If I read it and I go, this could have been more clear, you may lose points. In general, to be more clear about things, you add some extra words. So there's a lot of different answers I will take. You don't have to say word for word what you see here. The ages of the 10 Rio Hondo students that we talked to, the ages of the 10 Rio Hondo students that were polled, the ages of the students we talked to at Rio Cafe. You could put the number 10 in there or not. You could put Rio Cafe or not. You could put noon or not. But if you just say ages of students, you know what I mean? I'll be like, wait a minute, which students? You know what I'm saying? So
Yeah.
So just be clear. And sometimes, to be clear, you throw in a few extra words to make it a little more clear.
Okay.
Okay, so that's how you visualize these 6 components. Now, those 6 parts of a stats problem have vocabulary words associated with them, so I'm going to give you those words now. Every stats question is about a big group, and that big group is called the population. Okay, population is different than what you may think it is, because in the real world, when you say population is a number. Like, what's the population of Whittier? 80,000 people or something like this would be like how many people live in Whittier. But that's not what population means in a stats class. Population is not a number, it's a group of people. It's not always people, but it's the big group that the question is about. Usually it's people. Let's see what I wrote here. So the population is the large group of objects. Usually it's people, but it's not always people. That's why I wrote objects that we're trying to answer a question about. Okay, do we collect data from this group of people?
No.
No, we don't collect data from them. Okay, but if you imagine someone collected data from them, again, we're not going to collect the data from these people, but if you imagine it, you're going to visualize it as a big bag of numbers, and it's called population data. It's also called a census, but we're not going to use that word again. Okay, so population, big group of people, population data is data collected from the population, but we're not actually going to collect it. So it's an imaginary bag of data. So visualize this as a big bag of people, and this is a big bag of data if we were going to collect data from the people, but we're not. Okay, population data is the data from the entire population. Okay, now let me show you some of my pickiness. Okay, if you were going to write, if I ask you to explain population data, there's certain words you can use that make your answer wrong. And you're going to go, wow, you're really picky. But I just want you to pay attention to these things. Notice what I wrote. I wrote data from the entire population. I didn't write data collected from the entire population. That makes it wrong because you didn't collect it. Okay? So I want to make sure it's clear. We don't collect it. Or data obtained. These are words I did not put. Data obtained from the entire population. You don't want to write these words. It's just one extra word, but all of a sudden it makes it sound like you collect the data, which you don't. Okay, so let's make sure you're clear. Population data is not data. It's an imaginary bag of data if we were to collect this data, but we don't. Okay. All right, and if we did have this data, we could calculate one number from the data. Like in the last problem, we wanted to know the average of all these numbers, the average age of all Rio Hondo students. But it's not always an average. It could be a percentage or some other number. But if you collect, if you have population data and you calculate a number from it, that's called a population parameter. So a population parameter is a single number. It's one number that could be calculated if you had this data, but of course we don't. Okay, population parameter is a number that can be calculated from the population data, but it's unknown because the population data is unknown. So these 3 words have to do with the 3 big groups. Let me go back a couple slides here. Okay, so back to this slide. So this is the population, big group of people. Visualize it as a big bag with people in it. This is the population data. This is data from the population if we were to collect data from the population, but we don't. You visualize the population data as a big bag of numbers. And again, we don't have this data, but if we had it and we calculated a single number from it like this would be called the population parameter. Population data, population parameter. But the population parameter and the population data are unknown. So you just, like the population data is an imaginary bag. You can visualize it, but we don't actually have the data. Okay, and the bottom 3 things also have vocabulary words associated with them. Let me go forward here. So the small group of, actually, let me back up. Is there one more thing here? Yeah, so it says the population parameter is a number. It's the number we're trying hard to figure out, but we don't know it. So our ultimate goal in any stats problem is figure out what this number is. But it's really hard to figure it out when you don't have this data. But our goal is figure out that number. So we're dying to know what the population parameter is, but we don't know it. So again, what do? We collect data from a small group, not the entire population, not the entire big group, but from a small part of the group. That group is called the sample. So a sample Just like population, a sample is a group of people. It's not always people, but it's a small group of people, and that's the people you collect the data from. Let's see what I wrote over here. A sample is a smaller group of objects, usually people, but it's not always people. That's why I wrote objects that we collect the data from. So you're going to visualize that as a small bag with people in it, even though it's not always people. Okay, do we collect data from this group?
Yes.
Yes.
Yes. And that data is called sample data. The sample data is the data obtained from the sample. Now, this time I wrote the word obtain, and this time it's fine because we do obtain it. Or you wrote collected from the sample. That's totally fine because we do collect it. Okay, that's no. Visualize sample data is a small bag of numbers, and we have those numbers so we can calculate with them. Now, if you take the sample data and calculate a number from it, it's called a sample statistic. Okay, so a sample statistic is a single number. Okay, it's calculated from the sample data. We can calculate it because we have the data. And that's our guess for the population parameter, but it's a bad guess. So sample statistic is a single number calculated from the sample data, and the sample statistic is used to estimate the population parameter. It's a bad guess, but it's a guess. Okay, so I'm going to show you a visualization one more time of the same thing. I keep telling you the same story. I'm just going to keep telling you. That's how important it is. And then make sure by next class you really have all the pieces understood. Okay, so there's 4 different population parameters that we're going to look at. They're going to be the most common ones we're going to look at in this class. So here's a picture of the population data. Remember, that's unknown. And the stats question is going to ask you to find a number, right? Just like the last problem. Find the average age of all Rio Hondo students. But it's going to ask you to find some number. Okay. So what I'm doing in this slide is I'm going to basically give you some symbols, and they're going to be reserved for the rest of the semester. So if the problem asks you to find a percentage, so if it says, what's the percentage of all people in California that are married? If they ask for a percentage, the symbol is going to be P. Little p is going to be reserved for the rest of the semester to be a percentage, but it's a percentage involving a big group of numbers that we don't have. Okay, that's one kind of problem. It could say find a percentage. If the problem says, let me click one more slide over. Okay, population proportion or population percentage. Or the problem can ask you to find an average, like the last problem, find the average age of all Rio Hondo students. The symbol for that is mu. Okay, that's what that symbol is. It's called the population mean. So the stats question could ask you to find this. In a different stats question, they could ask you to find this. Okay, percentage of all people in California that are married, or average age of all Rio Hondo students. So those symbols are reserved. When you see mu, it's an average of all the numbers in a big group. When you see p, it's a percentage in a big group. Okay, the other things that they could ask you for is a standard deviation. Now, if you don't know what that is, that's okay. I'm going to teach you what standard deviation is next class. For right now, I just want to show you the symbol. So problem can say, what is the standard deviation of the ages of all Rio Hondo students? And the symbol for that is sigma. There's a Greek letter. It looks like a circle with like a line on top kind of thing. Okay, that's called the population standard deviation. They keep writing the word population to emphasize to you that it comes from the big group. Okay, that's the symbol for standard deviation. And then there's another one they can ask you called the variance. That's something else we'll talk about next time, but the symbol for it is sigma squared. It's just the square of the standard deviation, population variance. So these are 4 separate stats questions, okay? So when you're reading a stats question, you have to go, are they asking for a P? Are they asking for mu? Are they asking for sigma or for sigma squared? So you got to read the question carefully and know which one it is. And what are we going to do? We're going to take a sample. We're going to collect data from the sample. Here's a small bag of numbers of sample data. And we're going to calculate the corresponding thing down for the sample data. See, we can't calculate these because we don't have this bag of numbers. But we can calculate the corresponding things down here because we do have those numbers. If you calculate a percentage from a small group, the symbol is going to be p hat. Okay, p hat. All right. So p hat, what's the difference between p and p hat? They're both percentages. What's the difference? The difference is p hat is calculated from a sample and p is calculated from a population. Therefore, p is unknown, p hat is known. And p hat is called a sample proportion. So for the rest of the semester, when you see p hat, we're talking about a percentage calculated from sample data. So this is like kind of like one kind of problem. We want to know p, you calculate p hat, and that's your best guess for p. Or if it's an average problem, you would calculate the average over the numbers on the bottom. The symbol we're going to use for that is x bar. Mu and x bar are both averages. What's the difference? Mu is the average of all the numbers in the big bag, so therefore it's unknown. X bar is the average of all the numbers in the small bag, therefore it's known. And x bar is going to be my best guess for mu. So those are both averages. It's called sample mean or sample average. Okay, so I'm just showing you these symbols and they're reserved for the rest of the semester. If we were trying to guess sigma, which is standard deviation of these numbers, what we would do is calculate the standard deviation of these numbers. And the symbol for that is S, just little lowercase s, that stands for standard deviation. And again, notice they all say sample because they're all calculated from a small bag of numbers, which is known. And if you're doing a variance problem, if you want to know sigma squared, you're going to calculate the variance down here. And the symbol for that's going to be S squared. That's called the sample variance. So again, there's 4 different kinds of problems. Oops. If the problem says, figure out the variance of all these, sigma squared is what you're looking for. What do? Take a sample, calculate S squared, the variance of those, and S squared is your best guess for sigma squared. If the problem says, calculate the average of all these numbers, so you want to know mu, what are you going to do? Take a sample, calculate the average of those, and that's your best guess for mu. Okay, so just a bunch of symbols. Okay, one more time. This is kind of like the whole picture. So population visualizes a big bag of people, sample, small bag of people. Population data is a big bag of data from the population, but we don't collect it, so it's an imaginary bag of data. Sample data is the data that we collected from the sample. You imagine that as a small bag of numbers. And we want to know a number called the population parameter. And again, there's 4 different ones that could be asked of you. They could ask you to find a percentage, P, and the way you would do it is you would calculate P hat. So P is the percentage of yeses here, and P hat would be the percentage of yeses down here, and this would be your best guess for P. Or in a different stats problem, they might ask you to find mu, which is the average of all these numbers, and what you would do is you would calculate the average of all these numbers, and that's your best guess for mu. Or they can ask you to find sigma, which is population standard deviation. You would calculate the standard deviation of the numbers on the bottom, S, and that's your best guess for sigma. And if they ask you to find variance, your best guess is S squared, the variance for the numbers down here. Okay, so that's how the story goes. Okay, so now finally, we're going to do 2 examples, and the quiz you're going to have is going to be just like one of these examples. It's going to be similar. All right, here we go. First question. In order to figure out the percentage of people who live in Las Vegas and work in a casino, Greg went door to door and asked everyone who lives on Mountain Vista Street if they work in a casino. Of those 72 people Greg asked, 54 said they work in a casino. Okay, those couple of sentences outlined a story for you. And from that story, I want to pick apart all these 6 pieces, okay? Let's read it one more time. So we want to figure out the percentage of people who live in Vegas and work in a casino. In order to figure that out, Greg, we're not going to talk to everybody in Vegas. Greg went door to door and asked everyone on Mountain Vista Street, on one street, if they work in a casino. Of the 72 people Greg talked to, 54 said they work in a casino. Part A, what's the population? Who could tell me the population?
Everybody that lives in Las Vegas.
72.
People
Okay,
who
so
live
first
in
of all-
Vegas that work at a casino.
Okay, so good. I got all the answers I was expecting, but let's make sure we get it. So first of all, population is a big group of people, so you got to talk to me about the people. Don't just say numbers, right? So you want to give me people. Now, there were 2 answers I heard. One of them was all people who live in Vegas, all people who live in Vegas. And the other one was all people who live in Vegas and work in a casino. So it's one of those. Okay, now, first thing to say is the word all is very important, so make sure you get the word all in there. So which one is it? Is it all people who live in Vegas or all people who live in Vegas that work in a casino?
Casino.
Hold on. Let me say something. So this is a percentage problem. Percentage problems typically are more complicated than average problems. So when you're studying percentage problems, spend more time on those. And that's why I have a whole separate video on percentages. There's a big group and a small group. But in percentage problems, The big group and small group are divided further into people that would say yes to your question and people that would say no. Okay? So I want to make sure you're clear. The population is all these people. What's the question? We're going to ask, do you work in a casino? So if this was the population, all people who live in Vegas that work in a casino, that means you're only going to talk to the only people you're allowed to talk to are people that work in a casino. Well, what are they going to say to you if you say, do you work in a casino? What are they going to say?
Yes.
They're all going to say yes if you're only talking to people that work in a casino. Percentage problems don't work like that. There's going to be some people that say yes, some people that say no. Okay, so the population is all of them. So if you say and work in a casino, that ruins the answer. Now I get it. This is something you're going to have to go over a bunch of times. Okay, so the population is all people who live in Vegas. I don't care if they work at a casino or not. Some are going to say yes, I work at a casino. Some are going to say I don't. So hopefully that's clear. So when it comes to percentage problems, the population could be further divided into yeses and nos, but the population is all of them, whether they say yes or no. If you add this, you're saying just the ones that say yes. No, that's not right. It's all of them, whether they say yes or no. Okay, so the answer to this is all people who live in Vegas, and stop writing. Don't write that work in a casino. That ruins the answer. Okay, does everyone follow me on this?
Yes.
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 All right. And then it says, what's the population data? Now, population data is not the easiest thing in the world to write down, but you have to ask yourself this. If I collected data from these people, what would the data look like? Well, I told you to visualize it as a big bag of numbers, but only for percentage problems. Visualize it as a big bag of yeses and nos, because this is a yes or no question. And that's also a dead giveaway that it's a percentage problem if there's a yes or no question going on. Because what are you going to do? You're going to ask, do you work in a casino? What are they going to say? They're not going to say 28. You know, they're going to say yes or no. They're not going to give you a number. They're just going to say yes or no, right? So what's the data going to look like if you collected data from all these people? It would look like a bunch of yeses and nos. So when you write the answer, you need to write it kind of like in three parts. First, you want to say what the data looks like, which is a bunch of yeses and nos. Then you want to say where it came from. It came from these people. And then the third thing you want to write down is what a yes and a no stands for. So here. So the first thing you write down is the collection of yeses and nos. What's the population data look like? A bunch of yeses and nos. Okay, so you're going to say collection of yeses and nos. Then you're going to say where it came from. It came from all these people. From all people who live in Vegas. So both of those are important. Let me know what the data looks like. It's a bunch of yeses and nos. And then tell me where it came from, because the sample data is also a bunch of yeses and nos. So you got to tell me, oh, population data comes from the population. So you got to mention them. And then the last thing I wrote down is what a yes and a no stands for. So a yes means they work in a casino, and a no means they don't. So really kind of three parts to answer this question. So everybody with me on this?
Yep.
Yes.
All right, let's move on. Let's go to the sample. What's the sample? Remember, that's a small group of people. Someone describe the sample to me.
People who live on Mountain Vista in Las Vegas.
Yeah, the people who live on Mountain Vista Street. Yeah. Don't write the people who live on Mountain Vista Street that work in a casino. Because again, the sample has yeses and nos in there as well. But the sample is all of them. Okay, if this is the population, this is the sample. Okay, but if you say that work in a casino, you're only looking at the yes people and you're kind of ignoring these. So the sample is all of those. So let's see what I wrote here. The 72 people who live on Mountain Vista Street that Greg talked to. But notice I didn't write that work in a casino. That ruins it. And again, also notice that I'm talking about people. If I'm asking you to describe a population or a sample, it should be people you're talking about. If I ask you for population data or sample data, it should be numbers or yeses or nos that you're talking about. Let's go to sample data. What's a sample data? Okay, again, if you collect data from these people, which we do, you first want to tell me what the data will look like. The data will look like a bunch of yeses and nos. So again, we're going to write down collection of yeses and nos. Then you got to tell me where it came from. It came from these people, the sample people. So let's see what it says here. The collection of yeses and nos that Greg obtained his answers from the 72 people who live on Mountain Vista Street. So collection of yeses and nos from these people. And again, I wrote down a yes means they work in a casino and no means they don't. Any questions? Okay, let's keep going. What's the population parameter? Now the population parameter is a number. We don't know what the number is, but I'm not asking for the number. I'm saying give me the symbol and describe it in words. Someone tell me what the symbol is.
P.
P. Okay, now I want you to describe it in words. So again, this is where we have to understand what a percentage really means. A percentage is a way of comparing the sizes of two groups. So whenever you describe a percentage in words, you got to write down three things. First thing you got to do is write down the percentage. Every time you're describing a percentage, you first write the percentage, and then you got to mention two groups. This is the imagine this is the population over here, and it's divided into people who say yes and people who say no. Okay, when you're describing the percentage, you have to first mention the entire group. So you have to mention two groups because that's what a percentage does. It compares the sizes of two groups. What two groups? First, the entire group. It's percentage of the population. I got to write down. It's percentage of all people who live in Vegas. That's the population. And then the other group you have to mention is just the part that say yes. That's what a percentage does. It always compares the whole group to the part that says yes. So which ones are the ones that say yes? Those are the ones that work in a casino. So now you have to write that. Okay, so when you're describing a percentage, you got to write it in 3 steps. First, write the percentage of, then write down the big group, which is the population, and then the part that say yes, which would be the people that work in a casino. The percentage of all people who live in Vegas that work in a casino. Also, don't forget the word all. Any questions so far?
No.
Okay. Sample statistic, pretty much the same thing. First, you got to give me the symbol. Somebody give me the symbol.
P hat.
P hat, right. And again, when you're going to describe it in words, you're going to say it in 3 steps again. You're first going to say the percentage of, and then this is the sample now, okay? And the sample is divided into yeses and nos. After you write down percentage, again, percentages compare the size of 2 groups. So you have to mention the 2 groups. What are the 2 groups? The entire sample, and then the part of them that said yes. The sample are the people who live on Mountain Vista Street. The people that said yes are the people that work in a casino. So the way you write this in words is the percentage of, that's the first part. Then here's the sample, the 72 people who live on Mountain Vista Street. That's the sample. And then here are the people that said yes that work in a casino. So it's almost the same as this, except the middle part changes from the population to the sample. Everything else pretty much is the same. And because we have the data, we can actually calculate this number. That's why I asked for the value. Now, when you're calculating a percentage, you're going to make a fraction. The bottom number is going to be how many people are in the sample total, which is 72. So that's how many people are in this. And then how many people are in the smaller group go on top. Number of people that said yes always goes on top. And this problem says 54 people said yes. So when you're calculating a percentage, always put the size of the big group on the bottom. When I say big group, I mean the sample. The size of the sample on the bottom and the size of the part of the sample that said yes. Number of people that said yes always goes on top. So 54 over 72. If you put them in the calculator, it's 75%. All right, that's part F. Any questions? Okay, and then the last part of this example is going to say, make a guess for this, because we don't know it. Our best guess is going to be this. But there's a way I'm going to want you to write it. Okay, so your best guess for P is P hat. Okay, and P hat is 75%. Here's how we're going to write that. So what is your best guess for the percentage of people who live in Vegas and work in a casino? Here's how I want you to write it. So P is what we're trying to guess. I want you to write that it's approximately equal to P hat. That squiggly equal sign means approximately equal to. So P is approximately equal to P hat, which is equal to 75%. This is exactly how I want you to write it. Okay, so there it is. Any questions on example 1? Okay, we do have another example to do. Let's knock it out real quick. All right, here we go. In order to figure out the average age of all current Rio Hondo students, Greg asked the 40 students in the stats class for their ages, and here are the ages. Okay, just from those couple of sentences, same thing. I want to figure out what's the population, what's the sample, all that stuff. Someone tell me the population.
All current Rio Hondo students.
All current Rio Hondo students. Don't forget the word all. In the problem, I might not put the word all, but you still got to make sure you put it. Okay, it's very important. All current Rio Hondo students. Any questions so far?
No.
Okay, so then the next part says, what's the population data? So this is not a percentage problem. In a percentage problem, population data would be a collection of yeses and nos. But for any other kind of problem, it's going to be a bunch of numbers. What numbers? It's going to be the ages of these people. Age is a number. So population data is the ages of all current Rio Hondo students. We good?
Yeah.
Yes.
Okay, let's go to the sample then. What's the sample in this problem?
The 40 students in a stats
40
class.
students.
Yeah. The 40 students in Greg's stats class. Again, if you're not sure, put a couple extra words. I don't want you to put just 40, you know, or don't just put Rio Hondo students. This is not clear enough. Which Rio Hondo students? The ones in my stats class. So if you put the number 40 or not, that's up to you. But don't just write 40. Okay, the 40 Rio Hondo students in Greg's stats class. Those are the people whose ages we gathered, and the sample data are those ages. It's the ages of these people. So again, you have to ask yourself, what does the data look like? It's a bunch of ages, and where to come from these people. Okay, so it's going to be the ages of these 40 students. So basically, this is the sample data here. Questions so far? All right, sounds good. Let's go to the next one. Population parameter. Again, that's a number. It's unknown, so I'm not asking for the number, but I want the symbol and I want you to describe it in words. Someone tell me the symbol.
P.
So just so we're clear, this is not a percentage problem.
The
Oh.
population mean.
Yeah, it's mu. This is an average problem. So it's in order to figure out the average, right?
Yeah.
Okay, so the symbol is mu. All right, who can describe it in words?
The average age of all current Rio Hondo students.
Wonderful. Yeah, the average age of all current Rio Hondo students. So check it out. This is the population, all current Rio Hondo students. The ages of all current Rio Hondo students, that's the population data. So we just tacked on the word age, and now we tack on average, the average age, that becomes the population parameter. Okay, that's all we can do for part E because we don't know the number because we don't have the data to calculate it. So now we go to the sample statistic. What's the symbol for the sample statistic?
Um,
The X with the line. I don't know.
Yeah, that's right. X bar it's called. Yeah, X bar.
All right.
And then if you describe that in words, it's the average age not of all current Rio Hondo students, the average age of who?
The 40 students.
40 students.
Yeah, it's the average age of the 40 Rio Hondo students in my class, right? And it says give the value. You could give the value because we have the data. The value is already given over here, 23.25. So the answer is 23.25 years old. Okay, and then the last question is going to again ask you to guess this. What's your best guess for this? This. But there's a certain way I want you to write it. So let's see here. What's your best guess for the average age of all current Rio Hondo students? So you're going to write down, so mu is what we're guessing. You're going to write that it's approximately equal to what?
X bar.
X bar.
X bar.
And then write down that X
20.
bar is equal to 23.25 years old. Yeah, that's how that one goes. Okay, guys, we're done for today.